Good day, sir. My name is Jun Lim Jaji, matrix number DD220050. I am from Section 1, Group 1, and I'll be presenting the introduction part for this report. First of all, I would like to explain about what exactly the suspension system is. Suspension system is the thing that connects vehicle chassis to the road surface. The three main functions of the suspension system are: provides support, stability, and control. Second, absorbs shocks and vibration from uneven road surface. And lastly, manage forces during acceleration, braking, and cornering. Next, there are three types of suspension system. The first one is dependent suspension system. As you can see in the picture, its wheels on an axle move together as a unit. It is a simpler and cost-effective design. It provides stability for everyday vehicle. The examples for the dependent suspension system are solid rear axles and torsion beam suspension. The second type of suspension system is independent suspension system. As you can see in this picture, each wheels move independently. It has better wheel articulation and contact with the road. It enhances ride comfort and handling. And normally this type of suspension is common in modern passenger car and high-performance vehicle. The last one is semi-independent suspension. This is one of the examples of the semi-independent suspension. This type of suspension combines features of independent and dependent system. It is able to balance the performance and cost effectiveness. It is a suspension that has some independent wheel movement, meanwhile connected to a common axle or beam. Normally, this type of suspension is used in compact and mid-sized vehicle. Next, these are the main components of a suspension. The first one and the most important component is the spring. It stores and releases energy to absorb shock and maintain vehicle height. The second component is the damper. It controls oscillation of the suspension system, ensuring a smooth and controlled ride. The third component is control arm. It connects suspension component to the vehicle chassis, maintaining a wheel alignment and controlling the wheel movement. Next, we have the stabilizer bar. It reduces body roll during cornering, enhancing stability by connecting the left and right side of the suspension system. And finally, we have the bushings, which acts as a vibration isolator, reducing noise and harshness while allowing controlled suspension movement. Next, we have four main parameters that influence the design and tuning of a suspension. The first parameter is vehicle weight and weight distribution. Secondly, we have vehicle track. Thirdly, we have ride height. And lastly, we have steering geometry. That's all for the introduction, and I will pass it to my next teammate. Thank you.
Hello, my name is Kang. I'm going to introduce how the physical model of the suspension system is. Before we start decorating the physical model, we go to some place to buy equipment such as Mr. DIY, Raja hardware store, and also Proxim hardware store. Next, we go to the hardware store to buy the four wheels as we are modeling the car suspension system. Also, we have go to the motorcycle accessory shop to buy the clutch spring. Moreover, we go to the furniture store to buy the wood floor and our platform for our physical model. We go to the furniture store and meet up the general shop owner. He gives us the scrap wood for free, but the corner and edge of the scrap wood are struck, so they need to be smoothly with the sandpaper. Moreover, we bought some pipes as we want to transform the physical model of the suspension system into the trolley. But considering the factor of cost, we decided to stop this decision. But not least, we stick all of the parts using the hot glue gun and also the binding tape like this. After stick all of the parts, we found that the spring has the wobbly problem. It cannot even stand up. So, in order to solve the problem, we add the four brackets in order to stabilize the spring and it prevents the spring from wobbling any further. After fabricating for about 10 hours, our product has been finally done. The total cost for this project is 59 ringgit 20 cents.
Hello, my name is Martin. I'm going to explain about the function of the parts in this physical model. So the main component of this physical model is the valve and also the spring. The function of this valve is to provide the motion to this model, and also it can distribute the weight evenly across the suspension system. The clutch springs is used to absorb the bigger bumps and also the impacts, which acts as such as the suspension system in the rear car. And other than that, we got some other components which is used to make out this model, such as the bracket, which is used to support the wheels and also the spring, so that it can stay in the position correctly, and also the board, which act as the body and also support this model.
Hello everyone, my name is Ong Kang Nan and I will present about how can the model be used to describe the behavior of the system. So first of all, we look at the sample of calculation first. From the free body diagram, when the suspension system is in dynamic equilibrium, we have four forces acting on the system, which are spring force plus a function of displacement at time, weight force, dynamic force, and damping force. In the static equilibrium situation, we have only two forces which are spring and weight force. Next, we apply the concept of force in equilibrium and we assume that the force acting downward are positive and the summation of force in the y-axis is equal to 0. Thus, we get the equation mg equal to kh. In dynamic equilibrium, the method is the same. After we derive and substitute all the value, we can get this equation. And by comparing with the general form of the homogeneous second-order linear ordinary differential equation, we can know that the value of A equal to 1, B equal to C divided by M, and C equal to K divided by M. After that, by applying quadratic formula and by evaluating the discriminant where b squared minus 4ac, we have three possible cases. In the first case, overdamping, the equation has two real and unequal root. The value of root are equal to this equation, and we substitute to the general solution to get the final equation. And after we get the final equation, we can plot for the overdamping graph. The method we use for overdamping is also applicable for critical damping and also underdamping. That's all from me. Thank you.
Hi, we analyzed the vehicle suspension system under three cases. This graph shows the combination of all three cases. In an overdamped system, the motion of the system returns to equilibrium without oscillation, but the return is slow. The system takes a longer time to reach equilibrium compared to critical damping. In critical damped case, the motion returns to equilibrium rapidly without oscillation. The system reaches equilibrium in the shortest amount of time compared to others. In an under overdamped system, the motion of the system continues to decrease to zero before returning to the equilibrium. The system reaches equilibrium more quickly but overshoots and repeatedly crosses.
Hi, good day. My name is Imiji and my matrix number is CD220070. And now I will present about the suspension system of the physical model, which is tempered mass spring system. So the figure below shows the physical model and the free body diagram of the system. In real car suspension system, it is typically includes dampers or absorbers, which is used to control the motion of the system. However, due to the budget limitations and the availabilities of the materials, we are unable to buy a damper or an absorber for our physical model. So in this system, it will experience a damping force, which is friction force or air resistance acting on the system in order to cause the system to stop. The spring of the suspension system will deflect when a mass is attached until a static equilibrium is reached. So here are the four testing that we have conducted to our physical model, which are going over a bump, stair, road irregularities, and moving on a road. So based on the calculation part, we know that there are three possible cases, which are overdamping, critical damping, and underdamping. In this physical model of the suspension system, the focus is on achieving critical damping. This is because the critical damping ensures that the suspension system responds rapidly to the disturbance or road irregularities and provides smooth and safe ride without excessive vibration. So in this video, we can observe that the suspension system of the car and the critical damping case are simulated in our physical model. However, it will oscillate for a few times due to the absence of the damper. So that's all for me. Thank you.
My name is Anka Kasinchi, matrix number AD20168. So I will be continue presenting for the conclusion part. So firstly, after conducting the study, it actually really improved our understanding regarding the suspension system in the vehicles. So this suspension system actually plays a critical role in supporting, stabilizing, and also controlling the vehicle. Throughout the study, we explore different types of suspension system, which are the independent and dependent system. We also discussed the components of a suspension system and their function. And next, we did analyze data from different scenarios, for example, the overdamping suspension system, critical damping, and also the underdamping suspension system. And we did find out that there are distinct responses or the different responses which we can obtain among all the systems. And we also fabricated a physical model of a suspension system. It actually allows us to observe the effects of physically, and we did recognize the limitations of our model too. Lastly, we would like to emphasize the significance of considering various parameters in suspension system design and tuning. So to sum up everything, I would say this study actually really helped us to broaden our knowledge regarding the suspension system and also the knowledge regarding our course, which is differential equation. And that's all for our Group 1 Section 1 presentation. Thank you.